Good evening, students. We are going to start in few minutes. Okay. Let others also join the session. Then the session will going to start.
Hi guys, we'll
Hello.
just start in a minute, okay?
Okay, ma'am.
Okay, ma'am.
So guys, yesterday where we stopped, can you just let me know?
Ma'am, we were talking about accuracy.
Yeah, right, exactly. Okay, just allow me a moment. Let me just open my file so that we can write there and we'll move ahead accordingly. Yeah. Uh, my voice is audible to you? Clear it is?
Yes,
Yes,
ma'am, it
ma'am.
is clear.
Yes, ma'am.
Okay, okay, fine, got it. Just a moment. Let me just find the OLAP file up and we'll continue that. Is my screen visible,
No, ma'am. No,
guys?
ma'am.
No, ma'am.
No, ma'am.
Okay, okay, fine. Just a minute. I'm just sharing that. Yeah. Now it is visible.
No, ma'am.
No, ma'am.
No,
Oh,
ma'am.
okay, okay. My voice is audible, right? Properly?
Yes,
Yeah,
ma'am.
ma'am.
Yes,
Voice
ma'am.
clear.
Okay, okay. Now,
Yes, ma'am. Visible.
Yes, ma'am.
vi-
Now it is visible.
okay, okay, fine. Okay, great. So we have gone ahead and discussed about confusion matrix and accuracy, right?
Yes, ma'am.
Okay, okay, fine, fine. Okay. So we'll start off today with precision, then recall, then we'll go ahead with the models. We'll try and analyze and utilize that KNN model, decision tree,
Start
the
this. What is
tree-based model we'll see because the in those sorry, sorry. Okay, okay. I just want to ask you something.
it?
Yeah, any Anyone is speaking and anyone is telling anything? Okay, just wanted to ask you about the project. Like, have you all submitted your project with the video, guys?
Yes, ma'am.
All of it has been submitted, like week 1, week 2, both project has been submitted.
Yes, ma'am.
Yes, ma'am.
Yes.
Okay, everyone, right?
No,
Ma'am,
ma'am.
those who's presented here should also submit.
No. For those who have presented, they don't have to record the video, but they have to submit the project. Siddha, you have submitted the project, right?
Yes, ma'am, I did.
Okay, fine. That's fine. So rest all the project, right? That is the key area because there from there itself your evaluation would be done. So you have to do it accordingly. Because if you make the project and don't make the video or don't submit, that is of no use. So you have to submit it. So hopefully all of you have submitted. Anyone is left? If anyone is left, please raise your hand.
Yes, ma'am. Ma'am, I very
You are left.
recently joined.
Okay, when you have joined. Okay, Kajal, I guess
Um,
I remember last week only we spoke, right? Or this
yes,
week
ma'am.
only, I guess we have spoken. Okay. Okay.
Yeah.
Try to do it or submit this week, like this upcoming week. Okay. Try and
Yeah.
submit it like that. And I guess 6 people haven't submitted, right? So why you have not submitted, Om Prakash?
Excuse me, ma'am.
Yeah.
Ma'am, Saket, I have also not submitted week 2 video actually because I have viral even now. So I have
Okay.
having difficulty in recording video. I've submitted the Jupyter notebook
Project you
file.
have submitted. Okay, fine,
Yes,
got it.
ma'am.
Fine. But try to do it by this weekend because this weekend you will be having week 3 project. So you try and submit it by this week, both the projects. Fine. Week 2, week
Yes, ma'am.
3.
Yes, ma'am. Yes, ma'am.
Okay.
I'll do it.
And who? Okay, fine. Okay, Saket. Dhanush, Om Prakash, what about you? Why you haven't submitted?
Ma'am, actually, I had placement in my college, ma'am. Tomorrow I will submit.
Okay, got it. So you have to record the video along with that, submit the project also. Fine.
Yes, ma'am.
Ma'am.
Okay.
Yes,
Himanshu,
ma'am.
yeah, tell. Yeah. Why you
I I submit my
submitted?
project, but I not submit video because I have
Why?
family.
Why you haven't?
Because I
You
have
have
medical emergency
what medical emergency?
in my family.
Okay, in your family. Okay, got it. So try to do it by this week because more extension can't be given. Try to do it by this week only. All 3 projects with all of the details should be there.
Okay, ma'am.
Yeah. So anyone else
Excuse me, ma'am.
asking me? Yeah, tell.
Ma'am, I submitted the week 1 project, but I didn't receive the week 2 project in the group, ma'am. I even mailed to the HR team, but I didn't receive anything.
Okay, fine. That we will be seeing. And you have shared the video also, right?
Yes, ma'am. For
Hasini,
week 1, I
share the
submitted,
video, right?
ma'am.
Got it.
Ma'am, I
You
share
also
the
have you
video on
submitted week
same.
1?
I submitted the week 1, ma'am, but I didn't get the week 2 project list, so I didn't do that.
I got it. Not an issue. Week 2 will be shared to you. And who was saying, Pranay, you have also the same issue you're telling, right?
Yes,
Yes.
ma'am. I didn't get any
So
information
you
about
are
week 1 or week 2.
okay, got it, fine. Okay. So Manshu, you have anything to say?
Yes, ma'am. Submit the
Don't worry.
project. Submit the project video on same email.
Yeah, tell. The mini project, that one, that mail ID.
Okay, ma'am.
Okay. Yeah. So Om Prakash, you are having high fever. That's why you haven't submitted. So have you completed the project? What exactly is the issue? Is it related to the video or related to doing the project only? Okay, whatever be it, guys, try to do it by this week because this is the third week going, and we do have like we are given with week one and week two. So that's why you need to do it by like the both the video and the project that need to be submitted by this weekend. Okay, this upcoming week you need to submit. This upcoming week we can give you the time because this week you need to work on the third week project also, but try to do it as early as possible. Fine. Aryan, you have anything to say?
Yes, ma'am. It's been 5 days since I joined and I didn't get my offer letter, neither the project list
I
of week one or
understand.
week two or
Okay, about the project list, I will ask to share it in the group again. And the offer letter things, please don't ask me because I am not the one to answer you about the offer letter. You need to wait. There are many person who have got it a bit late due to some issues. That would be different. Eventually discuss. You can discuss it with the HR department. They will address that. Fine. I am not the person to know about the offer letter stuff. Fine.
yes, ma'am. I have
And
already
about the
mailed the
project
HR,
details.
but they don't
Okay, got it.
reply.
Uh, just allow them some time. They will definitely revert you back. Okay,
Okay,
okay.
ma'am.
Just allow
Okay.
them some time. They will revert you back. And eventually, about the project details, I will ask to share the project week one and week two project list in the group once again. Fine.
Yeah, one more thing, ma'am. Could you please send me the PDF you are taught in in meeting,
Which PDF?
which through which you are taught teaching us right now, the which you are sharing a screen.
This one?
Yeah, this one.
Okay, because we are continuing with this one itself. Okay,
Yeah,
so
yeah.
once it's been done, we'll try and share. Fine.
Okay, yeah. Okay.
Okay. Okay.
Thank you, ma'am.
Okay. Uh,
Yeah,
okay. Fine. So let's just continue with the session now. Okay, we'll just continue with the session, and I will request all of you to submit the project with the video and the stuff by this week. Fine. Along with this third week also, third week project also. Because on Monday you have to present your project here in the session
Excuse
only.
me, ma'am.
Yeah,
Hello. Ma'am,
yeah,
this is Samank here. Actually, ma'am, I have
okay.
not been assigned any project till now. I have talked to the heads already, but they haven't
When you
assigned
have
any
joined
project
the
to me
session,
yet.
when you have joined the session, when you have,
Uh, Hello.
yeah,
Yes,
I
ma'am.
can hear
I have
you.
joined first of yeah, yeah, ma'am. I have joined to the 1st of September.
1st of September. Okay, because I guess Hasini, when you have joined Hasini,
Sorry.
On 26th August, ma'am.
okay, okay, fine. So, Samyak, you have joined later, this month only you have joined, right? So, I guess might be you have been added in the WhatsApp group later. So, I will ask them to share the project list again with you. So, from there you can take the access of the what of the project you can choose and how you can work on. So, based on that, you work on the project and submit the project. And like I guess you know the drill, what you need to do.
Yes, ma'am.
You
That I
will be
know.
doing it
I just
accordingly.
wanted
I will ask
wanted.
them to share the PDF file. Yeah, yeah. Week one project details and week two project details will be shared again. Fine?
All right. Thank you.
Yeah. Okay. So let us just concentrate on today's session now. So we'll just go ahead. First, we have done with this confusion matrix part. We are done with. Then we have done with. Along with that, we have done with the accuracy part. Now today we will be moving ahead with the precision. Okay. So we'll be moving ahead with precision. So anybody want to put in their view what precision actually is? Guys, anyone? No one? Am I not audible, guys?
You're audible, ma'am.
Audible, ma'am.
Okay,
I've
okay,
no
fine.
idea
Good.
about that.
Okay, fine. Understood.
Ma'am, can I?
So let me just tell you. Yeah. Anyone wants to tell? Please tell.
Ma'am, it is actually used for the measure of for accuracy for positive predictions.
I didn't get you. Can you come again?
Means we are using it for the positive additions.
Yeah, right. So what precision actually does? Precision measures how many of the
Ma'am,
predicted positive. Yeah.
ma'am,
Please tell. Yeah,
can
tell,
I,
tell. Yeah,
ma'am,
tell. Definitely tell.
yeah, it is a method, ma'am, or analyze to produce a specific result, ma'am.
Specific result.
Yes, ma'am.
Okay, let me explain. Okay, so
Yes, ma'am.
what precision actually is? Precision actually what precision does? Precision measures how many of the predicted positive are actually positive. Like, see, we do have the actual result with us, right? So when we have taken the example, we have seen that we have the actual result with us. And there, based on the model, based on the learning, model predicts something, right? So we need to check how many of the predicted positive result that the machine made were actually positive. Okay. So you understood what I told?
Yes, ma'am.
Yeah.
Yes,
So,
ma'am.
okay, so this actually what prediction is. So for all the people, the model says, suppose have diabetes because initially we were working with the diabetes data, right? So we have taken two positive, two negative for the patients where we have taken the total number of patients as 100, 40 as diabetic and 60 as healthy. So healthy, this is the actual data. This actually is the actual data. So what precision do? For all the people, the model says that have diabetes. So that actually is the people who actually have the diabetes in the actual data. Okay, that actually is precision. So now what is the formula? Sorry, excuse me, guys, just a minute. Hmm. Okay, sorry guys for this. So the thing is, we are going ahead with precision. So formula is TP, that is, sorry, just a minute. TP, what TP is? TP is the true positive value. What is, I have written F, sorry, it would be 2. TP, so TP is the total true positive value. Okay, so because in precision we are considering only the true predicted value or true value, so that we will be taking into consideration and will divide it by true positive plus false positive. Okay. So whatever be the total predicted value that we will be taking into consideration and will be dividing the true positive with the total predicted value, that is true positive and false positive. Like whatever is the total positive predicted value actually. Okay. So what actually we are doing here, we have taken the example like this. We have taken TF value as 35, 5 as the model predicted value. Like this is the prediction value, like T TF, I guess FN value we have taken it. This what it is. It is the FN value. Arey, who is this? Who has switched on the
मैकेनिक
mic?
वाला बोलो मैकेनिक इसमें
You
कौन नहीं
have
है
anything to say?
उस आवाज
Mohammed Adnan,
कौन
MD Adnan.
पतले पतला
You
इंजमाम
have
है
anything to say?
सीएससी का
You have,
एजाज
guys, please don't do it like this. Okay, please. Who have muted me now? Please don't do it like this. This won't be entertained. Okay? I was actually saying you, like making you understand something. Okay, we are discussing about the precision stuff. So what precision we are doing up here? So we are taking TP value and we are doing, we are just dividing it by true positive and false positive predicted value. So now what we have taken it down here, we have taken down TP value as 35. So we will be taking 35, and what we will be doing, we have taken TP value as 35 and false predicted value, false positive value that we have taken, that is 10. So we are done with this, and we'll go ahead, and what we will be doing, 35 minus divided by 35 plus 10, that is 45. That would come up around 0.778. 0.78. This kind of value we will be getting. So that is around 78%. Right? So this is the data. From this data, we have got the precision that is 78%. Okay. So out of all those total 45 patient whose value has been like whose predicted value is true, they like true positive value actually they have been predicted among all those among all those patients, we have got the values like the precision level to be 78%. Okay. So high precision, what high precision refers? High precision refers the model rarely gives the false prediction. Like high precision says the model generally predicts the true prediction. Whatever be the actual prediction, the models try and give the true prediction. So it's like model rarely gives the false prediction. That is the level of the model, that is it is going good. That is we are satisfied with the model. And if the precision level is low, it signifies that many times it gives the false positive value. So that is not required, that is actually making the efficiency of the model lower. So it is not able to predict the actual stuff correctly. So in that perspective, we are actually using precision to get the values accordingly. Okay, clear guys? Understood?
Yes, ma'am.
Yes, ma'am.
Everyone?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay, fine, great. So next we are going ahead with recall value. So anyone having idea what recall is?
Actual positive, how many were detected by the model?
Sorry?
Of actual positive values, how many were detected by the model?
Yes, how many have been correctly detected by the model? Yes, that is what recall value is. So, in simple words, we can say it like among all of these patients, like the total patient that we have taken, who actually have diabetes, and how many did the model predicted correctly? Okay, so that is actually the recall value. So what we do here, so we take the TP value by, we are considering the total, like how many value has been correctly predicted by the model. So that is total positive, like true positive plus false negative. This value we will take into consideration. So that is 35 divided by, so TP is 35 only, and we need to check what is the FN value. So FN is 5, So we'll take the value as 5. So we are getting 35 divided by 40. So we are getting it around the 0.87 like that. In this range, we are getting the value. So we are getting around 87% of the data, like 87% recall value we are getting. So what actually it implies, like out of this 40, because in total we have taken how many total predicted value? So we have taken 40. So out of the 40 patients who truly have diabetes, the model and the model detected accordingly, that is actually 87%, right? So this is actually the recall value. So higher the recall value, so what actually higher recall value says, it says that model misses very few error or very few uh, patients data who are actually having diabetes. So model misses very few data. And if the value is lower, that is the lower recall value, so it says the model misses most of the actual predictions. So it has predicted wrongly in some session. It has predicted wrongly. So that is the that is the case where we are taking into consideration recall. So guys, everyone understood what actually it is and how we are taking into consideration, how we are taking this matrix into consideration, evaluation matrix, all this evaluation matrix.
Yes, ma'am.
Yes, ma'am.
Yes,
Okay.
ma'am.
Yes,
Okay,
ma'am.
great. Okay, great. So after one thing I just missed, like in case of confusion matrix, once we have created the confusion matrix, we can also visualize the confusion matrix heat map. Okay, so let me just show you. Yeah, here we have the confusion matrix heat map. So this is the confusion matrix heat map. So we have taken imported the data, imported the libraries basically. Then we have gone ahead and taken it down. We have taken the y true value as this. This is the true value that we are getting, and y predicted value we have taken into consideration. Then we have used this confusion matrix because we have already imported from sklearn. So we have taken it down, and in attribute we have given the y true value and y predicted value. So along x I am taking the predicted value, along y I am taking the actual value. So that we have taken into annotation, and with SNS, that is the Seaborn actually. With Seaborn library, we are just going ahead and doing the heat map. We have gone ahead and choose the color also. I have taken blue. Anyone can take anything, red, green, anything you want, you can take into count. And what basically D says, can anyone say what D actually signifies up here? This FMTD. So it is format. It is format the annotation as integer. This says that formatting the annotation as integer. Because in case of heat map, we actually take into count with the integer, like the decimal integer. D stands for decimal integer. Okay, because we actually takes into count about the decimal integer. If we take 3, then we will be missing 3.5, right? So here we need to take into count decimal integer point. So that's why D we have taken into count, so that we getting through along with that. And annote equal to true, what it is, we need to write the numerical value on each cell. So each cell, this value is written. So I need to annote it against the cell. If I don't put it, then this won't be print against this cell. That's why I have used this to print it with the cell. And this is how we have put this heat map. Clear, guys? Understood?
Yes,
Yes,
ma'am.
ma'am.
Guys,
Yes,
Yes, ma'am.
ma'am.
Yes,
Understood.
ma'am.
everyone?
Yes,
Yes,
ma'am.
ma'am.
Yes,
Okay,
ma'am.
Understood.
so we'll move ahead and take a look with how we can just go ahead and learn about KNN classification. So how we can go ahead and work with KNN classification. So anyone have idea what KNN classification is about? How we can like what this algorithm says? Anyone wants to put in their view?
Ma'am, it clusters the nearest data points.
Okay, yeah. So any other thing you want to put in like that is the common thing like in a neighborhood. So it would cluster the stuff that is quite common. Like it is a classification algorithm. So it will just make the like segregation based on that. Uh, so we can understand that. Apart from that, anything you want to put in?
Ma'am, it uses the distance formula to calculate the points from to calculate the distance from different points for the target value. And on the
Yeah, exactly.
count of major vote, it assigns the value to the category.
Exactly. So it actually uses the Euclidean, like basically we do use the Euclidean distance only, that form to get in through with the data. Okay. So what KNN is? KNN is an intuitive uh, classification algorithm, you can say, to predict the neighbor of the very new data that the model will acquire. KNN, that is the nearest neighborhood, it checks the closest training point. That is, it checks the neighbors actually. Okay. Based on that, it takes the vote. It is a voting mechanism. It takes the vote. That is, what is the majority class? Like it thinks like it asks the neighbors, like what actually is the majority among you, right? And based on that, it gives the access to that. Okay, so here we need to take into count about the distance. We need to measure the closeness, or we use the Euclidean distance here. So we need to measure the closeness of the points, and k, that is the number of values that we will be considering now. We need to take into count with that, and we need to vote for that. Like what is the how many neighbor voted in that format? That is the value of k. That is how many neighbor we are choosing for voting purpose. That we need to take into consideration our neighborhood. Okay. So it is not like there is any training phase with the parameters to learn. It is not like that. It is and KNN for a very similar perspective, we can say that KNN is a lazy learner. It stores the data and does the work and then it predicts. Like it stores the data, go for this KNN, like neighborhood choosing, go for this voting part, and then when it's been asked to predict, it will be predicting. Okay, and it work well. It is very important point that KNN actually work with a small or a medium data set. Very when we are having a very huge data set, it cannot work good. So it clears the cluster structure and work accordingly, but it can be slow for the large data. If I am saying in that form, you can think it of like that. It is slower for larger data or any data that have many like higher dimension data. This doesn't work good. So this is a very simple, intuitive classification model. So clear, guys, what actually I told about KNN, where it is going good, where it is actually suiting, and where not.
Yes, ma'am.
Everyone
Yes,
understood?
ma'am.
Yes,
Okay,
ma'am.
fine. Okay, fine. So what actually stepwise we need to do? Let us take into count. Then we will be moving ahead with that. So very first step for KNN. So it's done. Now we are going ahead with KNN. So this is the model. So the step by step, the very first step we can think it of as we need to choose the K. That is, we need to choose the values. We need to choose our neighbor from where we will be taking down the votes, right? So we need to choose the K value. It is on ourselves, on based on what and what value we need to choose for K. That is on our part. We do have given the access on what point we can choose the value of K. But from a general perspective, since we are taking down the vote from that, so we generally took the odd value. Suppose we can took 3, 5, 7. We generally avoid even values because there might be chance that equal number of vote come for yes and equal number of vote comes for no. So in that case, it becomes difficult for us. So if we choose the neighborhood as odd only, then it would be help to reduce the ties. If there is a chance of getting ties, that would be reduced. Understood?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Any query till now?
No, ma'am.
Okay.
No,
No,
ma'am.
ma'am.
So the next step, what we need to do, we need to choose the distance matrix. What matrix we need to choose to measure the distance that we need to choose. So we need to choose, generally we do Euclidean. So we'll try and go ahead with Euclidean. So basically we choose the distance matrix. Okay. So now we need to inquire for new points. Okay, now for each we need to inquire for the new point. So after this, after it's been done, the model gets the new point. So what we do for the new points, we need to compute the distance of each of the training points. Whatever be the training point we got, we need to compute the distance to each of the training point. Now we need to sort the training point by distance like from in an order, like which have the major distance that will come later, then again and shorter to later. In that format, we need to just arrange or sort the training points after we have computed the distance for each of the training point. Okay, so then we need to take the majority vote for those K labels. Okay, for the weighted value or the K labels, you can think it of like that, and then in return, based on the vote, it returns the predicted label. Okay, so it is for the new points that it will come across. So these are the points that we'll be considering for the new points. Understood what I told?
Yes, ma'am.
Yes, ma'am.
Okay,
Yes, ma'am.
okay. So let us take a real-time example for understanding purpose. Okay, so let us take 7 label points. Okay, we'll take 7 label points. Along with that, we will first, what is the criteria that we need to do? We need to choose the K value. Suppose let me just choose the K value as 3. 3 is the odd value. It will prevent the ties if there is any. So based on that, I can definitely choose the K value as 3, right? And next, we need to go ahead and check for the values because we'll be taking the X value and Y value also. So it will be a 2D value, right? 2D point we will be getting it through. So to predict the label, the query point, this is called the query point, K or this K, this K3 is called the query point. So we keep Q, that is the query point, as 3 comma 3. So why we have given 3 comma 3, understood? Because we will be taking 2D points, then we will be taking X value also, Y value also. So we need to take the Q value as 3 comma 3. Understood, guys? This much understood. Any query till now?
Understood, ma'am.
Okay, okay, great, great. So based on that, we'll go ahead. So let us just take the data point like that. I'm just putting it in Excel so that it becomes easier and sorted also, because writing it there is bit difficult. So first we'll take ID. Next we'll take X value. We'll take Y value. We'll take the labels. On what labels we will be putting it, that will be taken. Right? So we'll be taking 1, 7 value we need to take, we have taken into count. Okay. Then X value, suppose we have taken value X. For Y, we will be taking 1. For X, we have taken 2. For Y, we will be taking 2. For suppose X, we have taken 3. We will be taking something different. We want to take 1. We can take next. We can take around 6. Here we can take it around 5. Sorry, 5. We'll keep it simple for easy, because we need to do it on hand here. We won't get the context of the like doing it on code. So we'll take it easy for us to understand also and work accordingly. Like, because we need to do it, how we are measuring the distance, what things we need to do, we need to check on that, right? So we'll keep it simple. We'll keep 5, 6, then we can take 2, 4, anything we can take. Now label. So what label we can give? We can give any of the label. We can suppose, let me give it A. It's also A. We can say B. We can just take it to 4, 1, 2, 1, 2, 3, 4, 5, 6, 7. A 1, 2, 3, 4. We have taken one left. We can take it as A. Understood? This is the data we are taking into consideration. Got it, guys?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes,
Okay.
ma'am.
So this is the data we have taken into consideration. So now what we need to do, we have already taken the K value as 3. We have already taken the K value as 3. Now we need to find the Euclidean distance. So what is it? It is actually square root of, just a minute, x q, that is this q value, x this point, minus the x value, whatever we have taken into count, and we'll do the square root of it. We'll take the square root of it. Now we'll do plus, and similarly we'll do it for y. Y underscore q minus y, we will be doing, closing the bracket, taking the square root, and closing the uh, uh, taking the square of it, and whole would be under square root. Understood, guys?
Yes, ma'am. Yes, ma'am.
Okay. I have a request. Can you just take a snap of this data and just let me know X, because I again then I need to switch it off to see what data I have taken. And one, please take the data of X and Y and tell me, okay, so that we can calculate the value accordingly.
Okay, ma'am.
Okay.
Okay, ma'am.
Done? Anyone did it?
Yes, ma'am. Yes, ma'am.
Okay, okay. Then
Yes,
I'm
ma'am.
just moving ahead there. Okay. So first, for the point 1, so here the point is 1. I guess first I see 1 comma 1, right?
Yes, ma'am.
Yes, ma'am.
Yeah. So 1 comma 1 is the point. So I need to go and down. I need to see xq, that is 3. 3 minus 2 do? Because it is 3 minus 1, that is this one, I need to do, and I need to square it down. Now I need to do plus, I need to do 3 minus 1. Guys, just a minute. I'm having just a minute. Sorry, guys. Actually, I was having cough. That's why. Okay. So we'll do the square of it. Okay. So then next step, what we will be doing? Am I audible to you,
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes, ma'am.
guys?
Yes,
Okay.
ma'am.
Okay. Fine.
Yes,
Okay.
Yes,
Fine.
ma'am.
So 3 minus 1, what we are getting 2, right? So square of 2 we will be doing. That is 4. I am writing straight away. And here we will be doing plus of it. Again, 4 we will be getting. So after plussing it down, we will be getting 8, right? Right, guys?
Yes, ma'am.
Yes, ma'am.
So now we need to do the square root of it. SQRT of 8. So I guess it is around 2.8.
Yes, ma'am.
If I'm not wrong, it is around 2.8. So what is the next point? Can anyone tell?
I'm 2
2
comma
comma
2.
2.
2 comma 2. Great. So 2 comma 2 will be taking. So similarly, we will be doing 3 minus 2. We'll be doing square of it. Now we will be doing plus. Then again 3 comma 2. Sorry, 3 minus 2. And we'll be doing square of it. Now we
हाँ
will be
किसी
again. Who is
दिन
this?
फॉर्म भरा था किसी दिन भरा था अरे वो तो मैं
Dish- Guys, why you are doing this? You should understand this, at least have some empathy on that part. Not an issue. So we had 3 minus 2, that is 1, and the square of 1 is 1. Again 1, squaring of we are getting, will be getting 2. Square root of 2 is 1.414, right? So this is the second point we have taken into consideration. What is the third point?
3 comma 1, ma'am.
3,1.
3 comma 1. Okay, good. So for this one, for what 1 comma 1, what was the label given? Tell me.
A, ma'am.
Is A.
Label A. Okay, fine. And 2, what is the label?
A, ma'am.
A. Okay, fine. So next is 3 comma 1, right? So what is
Yes,
the
ma'am.
label for it?
B, ma'am.
B.
Okay, fine. So label is B. So now again we need to do the same thing. That is 3 squaring it off plus 3 minus 1. Yes, 3 minus 1. 3 minus 1 we need to do. We need to square it down. Now 3 minus 3, that is 0. We'll be squaring it off. We'll be getting 0 only. Plus 3 minus 1, that is 2. Squaring it off, we will be getting 4. And square root of 4, we will be getting 2. Right? What is the third point? Like the fourth point, I guess.
6
6,
comma 5, ma'am.
6 comma 5.
6 comma 5. Okay, fine. So what is the label?
B, ma'am.
B.
Okay, B. Fine. So similarly, we will be doing 3 minus 6. We'll be doing square. Now we'll be adding. Now what we'll be doing? We'll be doing 3 minus 5. We'll be doing the square. Now we'll come down. So square of 3, that is 9. 3 minus 6, that is, 3 minus 6, that is coming up to be, 3. 3 square of 3, that is 9. And plus 3 minus 5, that is 2. Square of 2, that is 4. Right? So in total, we are getting 13. Sorry, 13, it is 3.6, I guess. Right? Can you
Yes,
one
ma'am.
confirm square or
Yes,
root of
ma'am.
13 is 3.6 only?
3.6 it is.
3.60, 605, I guess. Yeah. Next point.
7,7, ma'am.
7, 7. Okay. 7, 7. So we'll try and do it directly from now on because you people understood. So it will be 3 minus 7, that is minus 4. Squaring minus 4, we will be getting 16, right? Now again, the same thing, 16, 16, that is 32, and square root of 32, it is around 5.6, right? Next, and what is the label for this 7.7?
B, ma'am.
Okay, got it, fine. Next, tell me the point.
5,6.
5, 6. Okay, fine. So we did it for this, that is 5, 6, 5. The same thing we will be getting here because we are adding after all. So it will be around 3.6605. Yeah. So what is the label?
B, ma'am.
Okay. Next, any other point left? I guess one more should be there.
2,4.
2, 4. 2, 4. Sorry. 2, 4. So for this, what is the label?
A, ma'am.
Label A. Okay, got it. So now what we are doing 3 minus 2, that is 1. Square of 1 would be 1. And 3 minus 4, that is minus 1. And doing it the square of it, we are getting 1. So it is 2, and square root of 2, it is 1.414. Right? So we have got all of this stuff. So we have got it accordingly. So sorted distance, like distance we have got it. Now we need to sort it down. So first we need to check for this. We have got 1.414. I guess one more 4 we have got 1.414, right? So we have taken, this is the 7th point, right? So we'll take first this point because this is the 2nd point. So we'll take it first. So now we need to sort it. Now, point 2, point 2, 1.414. So what is the label for point 2? Tell me.
A, ma'am.
A.
A, yes. A we have got. Next, since it is 7th point, that is 2, 4, we have taken into count 1.414 we have got. So 0.7, 1.414. Its label is also A. Now next we need to check after 4, 1.414, what is the greatest?
2, ma'am.
Okay, 2,
3,
yes,
comma
yes,
1.
3 comma 1, right. That is of which point?
3, ma'am.
3, yes. Yeah, this one, 3. So 2 it is. And what is the label?
B, ma'am.
B. Okay. Then after 2, what it is? We have, I guess, 2 point something again. Yes, 2.8. It is 1, first label, point 1. So it is label A. Point 1. So what is the point 1? It is 2.8, right?
Yes, ma'am.
Yes,
And what
ma'am.
is the label?
A.
A.
Okay. So then after that, it is 5. We have got 3, 3.6. 3.6, I guess we have got twice, right?
Yes, ma'am.
Yes. 5 comma 6. This is the sixth point, and this is the fifth point. Sorry, fourth point. In between, we have got this one. So it would be point 4, then 6, then point 5. So point 4, that is 3.6. What is the label for that?
B, ma'am.
B, ma'am.
B. Okay. Next, point 6, that is 3.6. And what is the label for that?
B, ma'am.
B, ma'am.
Label is B. And then point 5, that is 5 point something, 5.6. 5.6. And what is the label?
B,
B.
ma'am.
Okay, level B only. Okay, fine. So we need to take the top 3, because our k value, what was the k value? K value we have taken 3. So
3.
we have to put the neighborhood like that. So we'll take the first 3 values. This one, and this one. Okay. So in this, while we take the vote, what is the label? We are getting 2 label A and 1 label B. So after voting, we got the value as A. The voted who have win, that is A. So for KNN prediction for the Q point 3 comma 3, would be taking the class A. Right? Understood?
Yes, ma'am.
Okay. Everyone understood?
Yeah, ma'am, understand.
Yes, ma'am.
Yes, ma'am.
So for
Yes, ma'am.
KNN Q value 3 comma 3, we will be getting the label as A.
Level A, ma'am. Yeah.
Yeah. Right? So this is how we are actually performing up, and this way we are actually doing this KNN classification. So what KNN classification like in form we need to keep in mind while going ahead and working with KNN. So basically we need to choose the K value very correctly, because the value of K is totally dependent based on this K value. It is very like the value is very sensitive. See, if we take around 5 values, K value as 5, 1, 2, 3, 4, 5, this value. So then also we are getting this A values only, right? After sorting, we are getting A value, because the problem was very simple. But if the problem was complex, then in that case, we might get as like suppose B value also for that case. If this value, suppose if this value is respective, it is A, if this value is B, then and we have taken the K value as 5, 1, 2, 3, 4, 5, then in that case, after voting, B value will win, right? Right, guys? Understood?
Yes, ma'am.
So
Yes,
we
ma'am.
need to choose the K value very carefully. And if we are doing feature selecting or feature scaling, in case of the data that we have taken into consideration, that also we need to do, like, it is very critical. We need to keep an access over there, like, because first we will be, while we will be features that we will be choosing, if that features are like the is of large range, then that will dominate the Euclidean distance. That will put effect, right? That is basic reason what we need to keep in mind while going ahead and choosing KNN classification. Understood? So we'll just go ahead and see how we can plot it down. This much clear? Everyone clear?
Yes, ma'am.
Yes, ma'am.
Okay, fine.
Yes,
Yes,
ma'am.
ma'am.
Yes,
So
ma'am.
here, yeah. So for the previous data, what we have done, we have setted an example, created an example. But for this, what I have done new, I have just imported the iris data set. So Python gave us some inbuilt data set, access to some inbuilt data set. Okay. So Python does help us to get access of some of the inbuilt data set. So from there, that is from sklearn data set, I have loaded iris. Okay, iris data I have taken into count from here. So as you know about iris data, there are four numerical columns. I guess iris data is very popular. All of you must have worked at least once in your life, right? While you have come up here, at least you have worked with iris data at least once, right? So that is
Yes,
the
ma'am.
that is the most popular data set in data analytics you can think of. So I have just loaded that and taken the X, like segregated the labels according X and Y. Y have kept as the target because I need to choose the label. So here also it has given the label, and then similar process as we do, we have splitted the data into training and testing. We did some of the feature scaling, pre-feature transformation we did based because we need to do the distance measure. We need to do the Euclidean distance measuring of the distance needs to be done. So I did some of the feature scaling up, then gone ahead with KNN classifier. I have taken the K value here as 0, and that I have mentioned it up here. That is n neighbors. We have taken the value as 3, and we have gone ahead and trained the model, like fitted the model accordingly. After we have fitted the model, we have just gone for any test value, we have predicted the value, and now we have gone ahead with the prediction, like the evaluation. It had predicted the evaluation, like accuracy rate for the confusion matrix. It has all printed it like that, and the classification report for y test and y predicted. So it has all printed it like that. So here what we are getting, the accuracy level is 1, that is it is 100% accurate. Because as you know, this Irish data is very easy, very like it is easy to go data, you can say. When you are not getting any data, you work with Irish data. It is like that. And the data set is very like it, you don't have to put any of the pre-processing tasks also in case of any Irish data. So basically here you can see that for this, because the data set was very simple, you are getting this kind of accuracy where the accuracy level is 100%. Understood, guys?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Everyone, I'm asking everyone. Only why two people are answering. Others are not there in the class or what?
Yes, ma'am.
Because this week the project is gonna be based on the model making, model training, model evaluation. Because all this we have studied in this session. So you have to implement it. So if things are not clear, you won't be able to implement it. Right? So for this only, for your betterment only, I am asking you multiple times.
Yes, ma'am.
Okay. So after this, we'll go to decision tree. So what decision tree actually does? So let me just go ahead and tell you in case of decision tree, what are the major steps that we need to take ahead for going ahead and checking for decision tree and what we actually put into in case of decision tree. So anyone have idea about decision tree? What these are actually tree based. So what actually is decision tree?
In this decision tree, there will be two solutions, but we have to take only one final solution, which will be our final answer. Means, for example, in our real life, we have situations like various situations in our life, but from the through the various situation, we select only one. So in the decision tree also,
Right.
we apply the same.
Yeah.
It works
So it
in
is.
voting as well.
Yeah, it is actually like tree based. So in tree, there are two branches coming down. Like in, I guess you are well aware about the tree structure. It performs that only, and accordingly, it follows the same rules and regulation. Accordingly, we need to choose the node basically. Okay, if it is yes or no, it is actually one very important thing in case of decision tree because this is decision tree is that kind of algorithm that works with both classification and regression type of problems. So decision is a machine learning algorithm that we can think of. It is a supervised machine learning algorithm that uses for both that can be used for both classification and regression kind of like data if you are having. Okay, so it is like a flow chart, or as we mentioned, it is like a trees of decision. Like there are two ways. Based on that, we are choosing one and going further to work on that. Right. So this is what it is. And next, what we take into count. Suppose we have categorical data. Yes, no, this kind of data we are having. So we split it into two forms and we choose it accordingly. And finally, we continue to split it until we get the final destination, or we call it as a leaf node. The final destination is called the leaf node. So that basically we are taking into consideration. So in real time or real life, we get the result. We get the question like, is it raining? So we our answer is yes or no. So based on this, we just go for it. Next, if we have another question, so if it is not raining, if it is sunny, then can we play outside? So it will be yes or no. Either if it is yes, then we what is our action? If it is yes, we will go and play outside because it is sunny, and no, because if it is no, we will stay at home and won't go outside. Right? So this is the example we have. Like in case of decision tree, this raining problem is like the problem that we generally like keep in mind, because that any website where you see this problem is must, like this example is must. So we just keep in mind with that only. So in case of decision tree, we do have the root nodes. That is the for the first question, the starting point from where we are starting. We have the decision node. We do have the branches. That is, branches means what are the possible answers, yes or no condition, and the leaf node. That is our final result or the final description or final decision basically. Okay. So we will just go through and see what are the steps what we need to follow in case of decision tree. So in case of decision tree, okay. So in case of decision tree, we make split. So there are two measures. Based on that, we do that. Based on that, we do make the split. One is Guinea impurity, and another that we can think of, it is the entropy or the information gain. Okay, so what is Guinea impurity? It measures how mixed our data is. Okay, what is the mix? What is the measure that our data is mixed? That actually is been counted by Guinea impurity. If all the points of the same class is like it is the same, if all the points are of the same class, we are counting it as the Guinea value is 0, right? So that is, we will be getting the perfect split. If the data is mixed, if the classes, the points are mixed, like it is not from the same class, it is mixed, then the Guinea value will come greater than 0, right? So this is a measure by which we can count it down. And next is entropy. Entropy, it measures the disorder. Like information gain or the entropy. Entropy is basically the measures the disorder, and information gain, it gives how much disorder is reduced, can be reduced after the splitting. Understood, guys?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, fine. So we'll just go ahead and see step by step how what we can perform in case of decision tree. So similarly, we will be loading, we will be considering that iris data set only. We will be going ahead and taking the libraries where we can import like the importing the training and testing fleet. We need to decision tree classifier or the tree plot that we will be doing. So here, similarly, we will be loading the data set, splitting the data set. We need to create the decision tree classifier, and we need to create the index, like the criteria Guinea we have to keep, and what is the maximum depth that we need to check it once. We need to check it what is the maximum, what is the maximum depth that we can think of, right? So like how deep the tree will grow, like the what is the levels basically. Third level, up to third level, we can make it to grow the tree. This actually what it does, it actually helps us to prevent the overfitting. And we have taken random to just randomize the state. Like after this, we will be taking into account the same. Then we have trained the model accordingly. We have done the prediction. We need to do the prediction for this purpose, and we have evaluated and get the accuracy value. Classification report, in what format we are getting the classification report. In classification report, we get the value of precision, recall, F1 score, support, all of this. And we have printed the confusion matrix. Then we have just visualized it based on the depth, what on what depth we need to put it, like it draws the actual decision tree that we get in through. And based on that, we need to add the names and whatever be it, we need to color that. So based on that, we have created a visualized decision tree. Okay, so let us show the result. The accuracy is 1. So classification precision is 1, recall value is 1, F1 value is 1, support value we are getting it like that. Next, we are getting the confusion matrix like this. And this is the data, like the decision tree, true or false for Guinea 0. That is, the classes are all same. The samples are 31. So we have not taken this because Guinea value is 0. Here Guinea value is 0.5 taken into that. Gone ahead. Here we have, based on that, we have gone ahead and grade two zero values we have gone into for sample one, only one sample got 0. For 32 we have got this. Similarly, this is the exact decision tree that we have gone, like my model has learned from this actually. Okay, understood?
Yes, ma'am.
Okay.
Yes, ma'am.
So we
Yes,
now,
ma'am.
yeah. So we have understood about the basic KNN. We have discussed decision tree. Now we will go ahead and understand some of the advanced algorithm we will be going and understanding, because we need to work with advanced level models, because that help and go fit in with any of the model that comes into with the access part, where that can be easily accessed. And if our data is bulky, if our data is like hugely generated or hugely what I can say spread it out, how we can, what kind of data or what kind of forms we can take into consideration, or the models we can take into consideration, we will be just seeing it through. Okay. So first is gradient boosting machine. This is also a tree-based model. So GBM, that is the gradient boosting machine. So it is a powerful machine learning algorithm that is used for basically classification as well as the regression. This is the part of decision tree only. This is the extended version of decision tree, because you see that decision tree works well with simple data. So for the simple data like Irish data, we got the accuracy as 1. So gradient boosting is the advanced version of it, where it is, we can say GBM is an ensemble method. So it actually combines many small models like that are actually the weak learners, that those weak model, on those weak model we are not getting much of the good accuracy. There a GBM actually combines that and make a strong model. Okay, so it is basically the model where that is used in case of GBM, that is decision tree. So what actually GBM does, when many small decision trees are built over one another based on different question or the same specifications, we get and try to solve some of the inconsistency or fix the mistake that the previous data already have, right? So combining this data, this value is for a single decision tree. And in GBM, what we are doing, we are combining more than one decision tree to make it work accordingly. Okay. So eventually we will be doing it the same thing. Here we need to put the estimator, learning rate, and the depth till what we need to go. In decision tree also we have put. So here we will be doing the, here at least we need to put the estimator and the learning rate, by what rate it will come to us. So we have done the same, loaded the data, fitted the data, created the boosting classification, fitted the fitted the data like it wants to. I want to train the model based on my training data, and then made the prediction and evaluation I have got. So I have got the evaluation as 1. Okay. So it is 100% accurate for the data I have chosen it. So next, XGBoost. It is another special kind of uh, modeling technique model that we can think of. XGBoost is stand for extreme gradient boosting. Okay, so it is the advanced version of gradient boosting. Before decision, after decision three, we have chosen gradient boosted technique, machine learning. Then that was the advanced version of decision tree, and this is the advanced version of GBM, that is the gradient boosting. Okay, so it actually regularizes and performs, like it uses the regularization. Like yesterday, we have learned about the regularization L1 and L2 that used to reduce the overfitting. So similar, we are using XGBoost over here in the similar word. So what XGBoost does, XGBoost use and combine GBM for the speed, accuracy, for better handling real world data, and also uses regularization to make our model work better. Okay, so the similar way we have worked, and we have created the XGBoost classifier, trained the model, made all of the prediction up, and evaluated the model. Okay, and the most advanced version that we can think of, that is the light GBS, that is the more advanced version of XGBoost. So that is also the same. There also we get in through with and work with the data, and it like what it does, it is the advanced version of gradient boosting as well as XG boost. So it works well for ranking problems. If we have any ranking problems, it works very well. So light GBM works good with faster data. Like it is make the like learning section very fast. It is light. It is scalable. So all of this based on that. So it is light GBM is the most widely used data that we can think it of. Okay, understood?
Yes, ma'am.
Yes, ma'am.
Yes,
Yes,
So
ma'am.
ma'am.
accordingly,
Yes,
if we
ma'am.
are working with huge data and the data is having some of the collinearity and we want to reduce the overfitting, and based on the data set we are seeing this like which model can work better or best in this form, so we can think of this light GBM. Okay, understood guys?
Yes, ma'am.
Yes, ma'am.
So there is
Yes, ma'am.
certain
Yes, ma'am.
great. So there is certain difference when we can consider about decision tree, GBM, XGBoost, and light GBM, because decision tree is a single one. In case of GBM, we are ensembling the trees. In XGBoost, we are trying and ensembling the GBM. Like in every case, we are like from GBM, XGBoost, or light GBM, we are trying and ensembling the trees. Like more and more trees are basically used to get it work better. It is like when you are working with huge data and you are working with the GBM, there might be condition that it takes time, like it is a bit slower in case of learning. Like it might, while you are running the code in collab, it might take around 35 to 40 minutes to make you give the answer of it, give the prediction, make the learning or the evaluation part at one go. Okay, so you need to keep waited for that. So for this, since GBM has the speed of medium, so we need to go. We want to work it fast. That's why we have came across with light GBM. It is very fast. It works very well. So because of that, in every section, since we have taken the iris data set, so for every data you can see the just a minute. Yes, the accuracy level is 1. That is 100% accuracy we are getting. Okay, understood?
Yes, ma'am.
Yes, ma'am.
So this is how we
Yes,
are
ma'am.
going and working with this latest and well-known data, well-known models, because they work well, very well. Not only well, very well with our model. It help our model to get good accuracy, and based on that, we can think of, like based on that we can think of and understand if our model needs any further hyper tuning, hyperparameter tuning, or cross validation based on like the evaluation we get in the first section, right? Understood guys? Everyone,
Yes,
everything is
ma'am.
understand, everyone
Yes,
Yes,
understood?
ma'am.
ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes,
Okay,
ma'am.
okay, great. So we'll just stop today's session here. So you will be given with the project related to this, and you need to work accordingly on the project. Fine.
Yes, ma'am.
Okay. So I will
Yes, ma'am.
suggest you, based on you, if your data is like this, try to use this kind of advanced models. Like in linear also, I have shown you lasso, I have shown you ridge, I have shown you elastic net. Here also, I have shown you XG boost. I have shown you like light GBM or also like GBM. So you can try all of this accordingly and train your model. Okay.
Yes,
Okay,
ma'am.
ma'am.
Okay.
Okay, ma'am.
And I
Okay,
do
ma'am.
have a
Okay.
suggestion. I do have a suggestion, right? So suppose you have been given with the model, like you have been given with the data, and you have to do this model training based on your data. So try and use three different models. Okay. and try to analyze what is the result or evaluation you are getting. And based on the three different models, try to use the best model whose evaluation matrix you are getting, the accuracy level is more you are getting. Try to just go ahead with that model and save that model for future reference using like you can like .pk file or .h5 file. You can just save the model for further use. Okay. After you are done with all of the steps, like EDA analysis you need to do. After EDA analysis you did, then you go for model training, model evaluation, model training. After model training, if it is there, if it is possible, if you are not getting accuracy, suppose the accuracy you are getting around 60, 70, around 71%, then try and go ahead doing the hyperparameter tuning. Okay. So if that works well, that is well and good. If your accuracy level increases, that is fine, but consider that under one model only. Okay. Suppose for the data you did linear regression. Okay. So linear regression you gave you the accuracy level of 65. You did hyperparameter tuning. You got the result as 66.23. Just an example I am saying. Okay, so this much you are done with the first model. Then again you will choose another model. So in this case, you might choose, if it is a multiple linear regression based problem, you can choose lasso. You choose lasso, you worked with lasso, then you do the hyperparameter tuning and cross validation based on the model that you have got. For lasso, suppose you got the accuracy as 71%. After hyperparameter tuning, you got the accuracy level as 71.5. It has increased 0.5, but it has increased, right? So you did that. After this second model has been done, go for the third model. So there you try to use elastic net. Okay. So in elastic net, try to use that. In elastic net, go ahead and work with it. Do the model training evaluation. Suppose in ElasticNet you are getting around 75% of accuracy. Okay. And after hyperparameter tuning, you saw it, that is, you are getting around 77% of accuracy. So after hyperparameter tuning in ElasticNet, you are getting the accuracy level more, right? So you save that model using you save it by .pkl file or .h5, sorry, M5, anything, model H5, sorry, model H5, pkl file or .h5, like that, try to save it. If anyone fails, like if anyone unable to save the model, that is also fine. Keep that, like at least try and do for three different models. If in your project it has not been mentioned with any of the project, then do it like this. Fine? Understood?
Yes,
Yes,
ma'am.
ma'am.
Ma'am, understood.
Yeah. Okay. So I guess everything you have understood.
Yes, ma'am.
Yes, ma'am.
Yeah. So do it accordingly. And this is the third week project. So on Monday and Monday, you have to just go ahead and uh, present the project that you have done. So try to make, like, suppose in any of the case in the first section you get the accuracy level very less. Don't worry, try and use the other model. If you are also getting the accuracy level around 70 or 65, 68, that is also fine. Not to worry. You can work accordingly. Try to use, like, insert. There are certain problems also. There, suppose for the first model, you're getting accuracy 61. Till you are going for the third model with hyperparameter tuning, your accuracy level increase by like 64, not much. That is also fine. But work accordingly. Follow the method. Fine?
Yes, ma'am.
Okay.
Okay, ma'am.
Okay, guys. Then we'll just wrap up our session today here. All the best for the project. Do well in your project and we'll meet on Monday. Yeah.
Yeah, ma'am. Ma'am, while going only, I will just say Happy Teachers' Day and do take medicine, take
Okay.
rest.
Oh, thank you. Thank you. Thank you so much.
Happy Teachers' Day, ma'am.
Thank
Happy
you.
Teachers Day, ma'am.
Thank you.
Happy
Thank you,
Teachers' Day,
Prakash.
ma'am.
I have
Happy
seen your
Teachers'
text
Day.
now. Thank you.
Happy
Happy
Teachers' Day,
Teachers' Day,
Thank
ma'am.
you,
ma'am.
guys.
Happy
Thank
Teachers'
you,
Day,
guys.
ma'am.
Thank you. Yeah, thank you very much. Thank you. So, accordingly, please work. Fine. And thanks a lot, everyone. Thank you.
Bye, ma'am.
Yes,
Bye
ma'am.
bye.
Bye.
Bye bye.
Thank you, ma'am.
Bye
Happy
bye.
Teachers' Day.
Thank you,
Thank
ma'am.
you.
Bye.
Goodbye. Bye, guys. Bye bye.